Alright, so 17 is asking us to do some more integrals. We're almost done, but not quite. So let's go ahead and get these done. So integral from 1 over root 3 to root 3 of 6 over 1 plus x squared dx. So this is really just a trig inverse integral, barely in disguise. 1 plus x squared equals 6 tan inverse of x, evaluated from 1 over root 3 to root 3. And this is equal to 6 tan inverse of root 3 minus tan inverse of 1 over root 3. And you might think that there's some really nice values for those, but that turns out to actually, what that would mean, sine of theta over cosine of theta would be equal to root 3. Does that ever happen? Yeah. When sine of theta is root 3 over 2 and cosine theta is 1 over 2, then we're going to get this. So where does this happen? This happens uniquely when theta equals pi over 3. How about the other one? Theta over cosine theta is 1 over root 3. Happens in the opposite scenario. And when does this theta happen? Sine is 1/2, cosine is root 3 over 2. That's pi over 6. So this is actually equal to 6 pi over 3 minus pi over 6. So multiply by 6, you get 2 pi minus pi is just equal to pi. Alrighty. And then part B asks us now to integrate minus cosecant squared of x over the square root of 1 minus cotangent squared of x dx. Alright, so I look at this and I notice this looks kind of like a sine inverse integral. I've got a 1 minus something squared in the square root, so that's making me think sine inverse. I see cosecant squared, that's a derivative of cotangent, so let's try that for u. So let u be cotan of x, then du is minus cosecant squared x dx. Alright, this is looking promising. So this integral then is going to be a du divided by square root 1 minus u squared. But then this is exactly the integral of sine inverse u plus c. Or now we plug in and we get sine inverse of cotangent x plus c. So a not too unreasonable u substitution helps us out. See, this one looks like a monster. So e to the x over e to the x plus 2 square root e to the x 2x plus e to the x 2e to the x plus 2e to the x plus 3 dx. Alright, this one looks pretty tough, but let's see what we can do. So that e to the x plus 2 down there in the numerator is looking suspicious, and I see its derivative e to the x on top. So let's try that. Let's let u equal e to the x plus 2. Then du is e to the x. I see a square root, and I see some stuff squared, namely that e to the 2x. So I'm wondering, what would the square be? So e to the x plus 2 squared would be e to the 2x plus 2e to the x plus 4. So I can rewrite this integral as e to the x integral dx e to the x plus 2 square root e to the 2x plus 2e to the x plus 4. But I only had plus 3, so I can subtract out a 1. We could have done the same thing by completing the square, pretending e to the x was called y or something like this. But this is essentially a completing the square problem. And now this is exactly equal to e to the x plus 2 squared. E to the x dx over e to the x plus 2 times the square root e to the x plus 2 squared minus 1. Now let's substitute in for u. Integral du, the e to the x dx goes away, over u times the square root u squared minus 1. This is secant inverse of u, which will be secant inverse of e to the x plus 2 plus c. Alright, so that one is difficult, but not undoable. Finally, d integral 1 over square root 9 minus x squared dx. So here we can just use the formula. We have the integral of dx over root a squared minus x squared is sine inverse x over a plus c. Apply that to this, and we get sine inverse x over 3 plus c. So that's the formula. If you don't remember that or you didn't write it down, you're not stuck. We can still do this integral, right? We would turn this into integral dx square root 9 1 minus x squared over 9, which would be integral dx square root of 9, which is 3, square root 1 minus x squared over 9 squared. Let u be x equal to 3, in which case u squared is x squared over 9. And then you get 1/3 integral dx root 1 minus u squared, but you have to be careful because du is 1/3 dx. So dx is worth 3 du's. So instead of dx, this is, this eraser is too big. This dx is actually 3 du's. So those cancel. And we're left, after we put the u back, sine inverse x over 3 plus c, just like we got over there. So in case you forget, it's still doable, but that's a formula that you are allowed to use. And that concludes number 17.